Section 3.2, Equivalent Fractions. Two fractions are equivalent if they represent the same value. Example, use parts of a whole to show that 1/2 equals 2/4. So remember that 1/2, you have a circle cut into two parts, and one of those parts is shaded in. 2/4, you have a circle, it's been cut into 4 pieces, and 2 of them are shaded in. And if we compare these two pictures, we see that they both represent the same value. In other words, they both have the same amount of a circle shaded in. This is what it means for these two fractions to be equivalent. 1/2 equals 2/4. We often want to express fractions using the smallest numbers possible. This is known as reducing a fraction. Use parts of a whole to reduce 6/8. So we have to start with a picture of 6/8. So here's our circle. We have to cut it into 8 parts. It's not perfect, but it's all right. And 6 of them are shaded in. 1, 2, 3, 4, 5, 6. The way we want to imagine doing this problem is gluing some of these pieces together to create larger pieces so that in the end we have fewer pieces. One way we can do this is we can see that by lumping these two together, and these two together, and these two together, and these two together, we can end up with pieces that look like this. This one's shaded in, this one's shaded in, this one's shaded in, and this one's empty. We attained these by gluing together pieces. This was actually 2 pieces before, this was 2 pieces before, this was 2 pieces before, and this was 2 pieces before. The important feature here is that these are all the same size, so that when we glue these back together again, we see that we have 4 total pieces and 3 of them shaded in. 6/8 equals 3/4. Example, reduce 6/8. Now we're going to do it the same thing this time except algebraically. 6/8 equals. Now the key to doing these problems algebraically is to find the greatest common factor of the numerator and the denominator. In this case, that's 2. So then we factor both of these numbers using 2. 2 times 3 is 6 over 2 times 4, which is 8. So 2 times 3 over 2 times 4. And what we do is we cancel the 2's. Now exactly what's going on here is related to the picture above where we've glued 2 pieces together into 1. Algebraically though, all we're doing is crossing out the 2's, same number on top as on bottom. And that leaves us with 3/4. Section 3.3, Equivalent Fractions Part 2. Sometimes it's convenient to express fractions with larger numbers as opposed to smaller numbers. Example, rewrite 5/6 using the denominator of 18. To rewrite fractions with a bigger denominator, we do the opposite of what we did on the previous section, which is instead of essentially dividing by a number, we are multiplying by a number. So we're going to look at the denominator. We want the denominator to be 18. 6 times what is 18? 6 times 3 is 18. And so we multiply top and bottom by 3. And we get 15/18. This is the process of rewriting a fraction with a larger denominator. Rewrite 3/4 and 7/5 with the same denominator. This problem is a little bit more involved. We have to figure out what denominator we can use that works well with both 3/4 and 7/5. Another way to say this is that we want to find a common denominator or a common multiple of the denominator. So we look at the numbers 4 and 5. A number that both 4 and 5 go into evenly is 20. So now we have to go through the process of rewriting each fraction. 3/4 is 3 times something over 4 times something. We want the denominator to be 20. 4 times what is 20? 4 times 5 is 20. So we multiply top and bottom by 5, and we get 15/20. Do the same process with 7/5. We want the denominator to be 20. 5 times what is 20? 5 times 4 is 20. So we multiply top and bottom by 4. And now we've written both fractions with this common denominator. Section 3.4, fractions as division. Example, reduce 24/4. 24 over 4. What is the largest number that goes into both 24 and 4? 4 is the number. 24 is 4 times 6. 4 is 4 times 1. And we cancel out the 4's, leaving us with 6. This calculation should remind you of 24 divided by 4, which is 6. And in fact, 24 over 4 is the same thing as 24 divided by 4. Another way of saying this is that fractions also represent division. Example, rewrite 37/5 as a mixed number. 37/5 equals. We're going to use the same process as division. How many times does 5 go into 37? Well, we can get up to 35, and then we'll have 2 pieces left over, which is 35 over 5 plus 2 over 5. This step mimics the distributive property, which is 7 and 2/5. So the process of rewriting an improper fraction as a mixed number simply follows the same pattern as division.